the night sky you've always known. It's a cosmic illusion. Every twinkling star you've ever wished upon, every familiar constellation that has guided sailors and dreamers for millennia, is about to be irrevocably altered, perhaps even erased from our view. And we're not talking about some distant, abstract future, not in a billion years, not even in a million. This is happening in a mere 12 months. A rogue galaxy, a celestial interloper previously shrouded and hidden behind the swirling dust lanes of our very own Milky Way, has been tracked, clocked, and confirmed. It's hurtling straight at us at an almost incomprehensible speed of 600 kilometers per second. The first, devastating pass is scheduled to rip through the heart of our Milky Way on August 17, 2025. There's been no grand public announcement, no frantic government press release, no emergency UN summit. Just a quiet, almost imperceptible footnote buried deep within a data dump from the brand new Deep Sky Sentry telescope. By the time you reach the end of this video, you won't just understand what's happening. You'll grasp, with chilling clarity, precisely why silence was the only option they believed they had. All right, picture the moon. That familiar, comforting orb hanging in our night sky. Now, stretch your imagination a bit further. Envision something 10 times wider than that moon, a sprawling, ethereal presence, glowing with an unsettling violet-white luminescence, rising tonight where our placid lunar companion should be. Sounds like something ripped straight from a particularly vivid science fiction novel, doesn't it? But here's the kicker, that's not fiction. That's the leading edge of Andromeda's evil twin, an entirely unknown galaxy we never, ever saw coming. Why? Because its stars are so ancient, so incredibly old, that their light shines almost entirely in the infrared spectrum, invisible to our human eyes and most of our conventional telescopes. Until now. Until 2025. It's arriving. So, stick around, because over the next few minutes, I'm going to walk you, step by chilling step, through the final year, the final day, and even the final hour before the Milky Way, our home, becomes nothing more than a shredded, chaotic halo of scattered stars. The discovery that didn't make the news. Let's rewind a bit, back to January 2024. Imagine a dimly lit lab in Bern, Switzerland. A brilliant, albeit slightly overwhelmed, grad student is deep into the tedious but crucial work of calibrating the brand new Deep Sky Sentry telescope. Her primary task? Hunting for rogue asteroids, those cosmic bullets, far beyond the orbit of Neptune. A fairly routine, if vital, mission. But then, something unusual flickers across her screen. A smudge. Not a glint, not a streak, but a persistent, stubborn smudge that absolutely refuses to move in the expected ways of any known celestial body. It isn't a planet. Its trajectory is all wrong. It isn't a comet, lacking the telltale tail. And yet, day by day, hour by hour, it's undeniably getting bigger. The smudge is resolved into something more defined, more galactic. Within a frantic 72 hours, the object has a provisional designation, Object X. The initial data is so baffling, so outside the realm of expected astronomical phenomena, that it triggers protocols rarely, if ever, used. Within a week, virtually every non-public antenna, every classified deep space observatory on Earth, is discreetly, silently, pointing its powerful gaze at Object X. The data streams in, torrents of it, confirming the impossible. Parallax calculations, refined with unprecedented precision, place its distance at a staggering 2.1 million light-years. Remarkably, almost precisely the same distance as our well-known galactic neighbor, Andromeda. But then comes the real shocker. The redshift is fundamentally wrong. Instead of the expected redshift, indicating an object moving away, this thing is blue-shifted by a mind-bending 1,800 kilometers per second. What did that mean? It meant that whatever this colossal, infrared-shrouded entity was, it wasn't just in our cosmic neighborhood. It was already inside our local group of galaxies, and it was barreling directly, unstoppably, our way. By March, the hushed, top-secret briefings began. Not just for scientists, but for the highest echelons of global political and military leadership. Imagine those rooms, stark, cold, filled with disbelieving faces as astronomers, eyes wide with a mixture of terror and awe, presented the undeniable evidence. By April, every astronomer, every astrophysicist, every data analyst with even the slightest clearance on the project was made to sign an ironclad non-disclosure agreement. A silence descended, heavy and absolute. The story, the most profound story in human history, died before it could ever breathe. Why? So the rest of us, blissfully unaware, could sleep soundly at night. But here's the spoiler, folks, the rest of us are about to wake up, and we're going to do it very, very fast. Why galaxy collisions feel gentle but aren't? From a distance, galaxies often appear soft, ethereal, like wisps of cosmic cotton candy spun across the canvas of space. That, my friends, is the universe's first, most profound deception. It's a trick of perspective that belies an unimaginable, brutal reality. Yes, the space asterisk between asterisk stars within a galaxy is vast. So vast that direct stellar collisions are incredibly rare, like trying to get two bees in separate football stadiums to graze wings in mid-flight. But the space asterisk between asterisk galaxies? That's an entirely different story. It's not empty. It's absolutely stuffed, brimming, with invisible dark matter. This mysterious, unseen substance outweighs everything we can see, everything that emits light, by a staggering 5-to-1. And when two of these dark matter halos, these colossal, invisible gravitational anchors, meet, they don't politely shake hands. They don't gently sidle past each other. They rip, they tear, they yank each other with gravitational forces that defy comprehension, accelerating at speeds upwards of 200,000 kilometers per hour. While individual stars might mostly miss each other, the gravitational fields that bind entire galaxies undergoing a violent, cataclysmic upheaval. Imagine the delicate, intricate dance of our solar system, every planet locked into its precise, stable orbit around the Sun. Now, introduce a colossal, unseen hand that begins to tug, to pull, to distort those familiar pathways. Outer planets, once comfortably situated, suddenly feel an entirely new, alien gravitational pull. Comets, typically residing in the distant, frozen Oort cloud, are dislodged from their slumber, sent raining inward towards the Sun, turning the inner solar system into a cosmic shooting gallery. The solar system's millennia-old, delicate balancing act transforms into a high-stakes juggling routine, with every celestial body's fate hanging precariously in the balance. The good news, if you can call it that in such a scenario, is that Earth probably won't be flung out into the desolate, frigid emptiness of deep intergalactic space. Our Sun, with its relatively stable planetary family, has a decent chance of remaining gravitationally bound, even if its orbit around the galactic center becomes wildly different. But, and this is a colossal but, that probably is doing an awful lot of heavy lifting in that sentence. It's a word clinging precariously to a cliff edge, hoping not to plummet into the abyss of cosmic uncertainty. The sheer scale of the disruption means that even if our planet isn't ejected, its environment, its very stability, will be profoundly, permanently altered. The gentle part of galaxy collisions is a myth. The reality is a slow-motion, gravitational car crash on an unthinkable scale. 1 year out, August 2024. The subtle shifts begin. It's August 2024, and the first whispers of the unthinkable start to propagate, not from official channels, but from the most observant and dedicated corners of the astronomical community, the amateur astronomers. They're the first to notice that the Milky Way, their beloved, familiar home galaxy, looks lopsided. The galactic center, that luminous heart of our spiral, seems to have shifted a few degrees off its expected position from last year. At first, they blame their equipment, Mount drift, polar alignment errors, maybe even a glitch in their astrophotography software, Photoshop artifacts. They tweak, they recalibrate, they curse their gear. But none of those fixes work. The anomaly persists. Then, the smudge from January 2024, now unofficially, and rather ominously, nicknamed Nemesis, begins to assert its presence more forcefully. It brightens, slowly but relentlessly, reaching magnitude 4. For the first time, it becomes visible to the naked eye from any sufficiently dark backyard, a faint, ghostly patch of light where nothing should be. Social media, that ever-present barometer of public curiosity and anxiety, begins to buzz. Forums dedicated to sky-watching light up with questions, theories, and increasingly, frantic speculation. Memes, a uniquely human coping mechanism, flood platforms like TikTok, depicting two cartoon galaxies shaking hands, or perhaps, ominously, engaged in a cosmic wrestling match. The astronomers who sign those NDAs, those guardians of a terrible secret, bite their tongues so hard they can almost taste blood. The internal struggle between their professional duty and their moral obligation to inform the public becomes an agonizing, personal torment. Meanwhile, in the less visible, more technical spheres, other unsettling data points emerge. Deep orbit satellites, those silent sentinels circling our planet, report a measurable 0.3% increase in cosmic ray flux. It's a tiny number, seemingly insignificant. But then, a peculiar observation from the International Space Station. Seedlings, part of a long-term experiment, are growing an extra, unexpected set of leaves. A minor biological anomaly in orbit. Nobody, not yet, links these two seemingly disparate facts, the slight uptick in cosmic radiation and the bizarre plant growth. But the universe, in its own slow, inexorable way, is already beginning to hum a different tune, a prelude to the symphony of chaos that's about to unfold. 6 months out. February 2025. Fast forward to February 2025. Just 6 months to go. Nemesis is no longer a smudge, no longer a faint patch. It now spans a staggering 8 full moons across the night sky. It's a colossal, undeniable presence, a vast, luminous cloud that seems to consume the stars behind it. The sheer amount of light emanating from this approaching galaxy is so immense that nighttime light pollution levels jump dramatically. Cities, accustomed to their artificial glow, find themselves bathed in an alien, violet-tinged luminosity. Many municipalities begin to dim street lamps, not just to save energy, but because the sky itself now casts an eerie, pervasive light. Earth's magnetic field, our planetary shield, begins to hiccup, then stutter, then lurch daily. It's like a tired heart struggling to maintain a steady beat. The culprit. The immense pressure front generated by the two colliding galactic gas halos, pushing against our planet's protective bubble. The effects are visually stunning, yet deeply unsettling. Auroras, those dancing curtains of light usually confined to the poles, bloom in vibrant, impossible hues over Bogota, over Mumbai, over Lagos, cities that have never witnessed such a phenomenon. Compasses, once reliable navigators, begin to drift by several degrees, rendering them increasingly unreliable. In London, flocks of pigeons, famed for their innate homing abilities, circle for hours, disoriented, unable to find their bearings. The disruptions aren't just biological or geophysical. Airlines, ever pragmatic, quietly begin to reintroduce celestial navigation classes for their pilots, dusting off archaic charts and sextants as GPS signals grow increasingly erratic. Then, the inevitable, the European Space Agency leaks an internal slide deck. The title alone sends shivers down the spines of those who see it. Impact scenarios. It's quickly retracted, dismissed as a training document, a mere hypothetical. But the internet, once it gets a whiff of something this big, never forgets. Reddit threads dissecting the leaked slides explode, hitting 3 million views in 4 hours before moderators, likely under immense pressure, nuke every single copy. Too late. The word galaxy trends at #1 worldwide for 36 straight hours, a collective, burgeoning realization dawning on humanity, a dawning that carries the chill of existential dread. The official silence is breaking, not with a bang, but with a torrent of terrified, speculative murmurs. 1 month out. July 2025. The calendar turns to July 2025. Just a month left. Nemesis is no longer just visible, It dominates half the entire night sky. It hangs there, a colossal, bruised purple river of ancient stars, its vast, swirling structure now clearly discernible, an overwhelming, terrifying spectacle. The sheer gravitational mass of this intruder is beginning to stretch and distort the very fabric of our own Milky Way's outer rim. Our Sun's orbital speed around the galactic center, a constant for billions of years, increases by an alarming 12%. That might not sound like much, a mere percentage point, until you grasp the implications. Earth's path through the spiral arms of our galaxy quickens dramatically, dragging us through dense, uncharted dust clouds that normally take millennia to traverse. The immediate consequence? Shooting stars aren't rare anymore, they're constant. Every single night is a meteor storm, a relentless barrage of incandescent debris burning up in our atmosphere. Every dawn reveals new, shallow scars on the moon's face, etched by impacts from nemesis's flung-off material. On Earth, the tides, already influenced by the moon and sun, begin to climb higher, reaching unprecedented levels, threatening coastal communities. GPS accuracy degrades catastrophically, reverting to pre-2000 levels, crippling modern navigation and logistics. Fiber optic cables, the arteries of our global communication, snap under enhanced seismic strain, as the planet itself begins to subtly groan and flex under the new, immense gravitational stresses. The charade of silence can no longer hold. Scientists, pale and visibly shaken, convene a live, globally televised press conference. The mask is finally off. The lead astronomer, her voice cracking with a mixture of exhaustion and profound gravity, delivers the unvarnished truth. Yes, two galaxies are colliding. Yes, the solar system, remarkably, will likely survive the first pass. No, we cannot predict its orbit afterward. The future of our star, and our planet, is now profoundly, utterly uncertain. The global reaction is immediate and devastating. The stock market, that fragile barometer of human confidence, opens 20 minutes late because half the traders simply didn't show up. The other half, paralyzed by disbelief and fear, watches indices plunge into a freefall unprecedented in human history. The world, for the first time, collectively faces a truth far grander and more terrifying than any war or economic collapse. The universe is a violent, chaotic place, and we are caught in its maelstrom. 24 hours. The final day dawns, or rather, the final 24 hours begin their inexorable march. The leading edge of Nemesis's vast, turbulent dust lane slams into the Milky Way's Perseus arm, a colossal, invisible fender bender on a cosmic scale. The impact is not direct in the way we understand it, but the compression of interstellar gas clouds is instantaneous and violent. They ignite, not in a gentle glow, but in a furious, blinding string of supernovae, each one a star dying in a blaze of glory. From Earth, the sky is not just bright, it's noon bright for a terrifying, disorienting 10 seconds, even in the dead of night. It's a sudden, unbearable flash that sears itself into the collective consciousness of humanity. Satellites, bombarded by the sudden surge of radiation and gravitational shockwaves, reboot en masse, their delicate systems overwhelmed. Power grids across continents drop into protective shutdown, plunging vast swathes of the globe into darkness and silence. Ham radio operators, the last bastion of independent communication, report an impossible phenomenon. Aurora, crimson and singing with static, flaring intensely at the equator, a vibrant, terrifying curtain of light. On the International Space Station, the crew, their faces etched with a mixture of awe and grim determination, record a video goodbye to their families and to humanity, a poignant message sent into the void. Then, with a desperate, last-ditch effort, they boost the station into a higher, more precarious orbit, hoping to dodge the incoming debris field. But the most profound, physically palpable change is something entirely new. Gravity waves, actual, measurable ripples in the fabric of space-time itself, begin to pass through Earth every 90 minutes. These aren't subtle, theoretical phenomena anymore. They are powerful, tangible pulses, squeezing and stretching the entire planet by perceptible centimeters. Seismometers, designed to detect the tremors of earthquakes, draw bizarre, rhythmic pictures that look uncannily like heartbeats on their readouts. Buildings creak, ancient geological faults shift, and a low, resonant hum becomes a constant, unsettling background noise. Noon feels like dusk, the sun's light filtered through an increasingly dense and chaotic cosmic haze. Midnight, when it comes, looks like a vast, bruised pink and violet palette, painted across the heavens by the dying light of distant, exploding stars. And this, remember, is just the foreplay. We haven't even touched the other galaxy yet. The moment of first contact. Then, it happens. The universe holds its breath. The two supermassive black holes, the monstrous hearts of their respective galaxies, ours, a relatively modest 4 million solar masses, and nemesis's, a gargantuan 30 million, pass within a mere 50 light-years of each other. That's an almost unfathomable distance in human terms, but cosmically, it's a hair's breadth. Their relative velocity at this terrifying closest approach? A blistering 900 kilometers per second. The gravitational forces at play are so immense, so utterly distorting, that space-time itself bends, warps, and shimmers. Through telescopes, stars visibly jitter, their positions shifting and dancing in an impossible ballet. For 7 agonizing minutes, a phenomenon called gravitational lensing turns the entire night sky into a hallucinatory hall of mirrors. Every star, every distant galaxy, is duplicated, stretched, smeared into impossibly long, shimmering arcs of light. It's a vision of ethereal beauty and profound terror, a cosmic kaleidoscope of distorted reality. Earth's atmosphere, bombarded by an unprecedented flood of radiation from the nearby black hole interaction, glows a faint, ghostly green as oxygen atoms are excited and then relax, releasing their newfound energy. The air crackles with an almost palpable static charge. Then, as suddenly as it began, a profound, eerie silence descends. The black holes, having exchanged a titanic gravitational embrace, slingshot violently apart, stealing momentum from each other, sending both galaxies reeling in their wake. The Milky Way's once majestic spiral structure unravels like thread from a spool, its graceful arms torn and scattered, its coherent form dissolving into a chaotic stream of stars. Nemesis, the aggressor, leaves behind a vast, shimmering trail of hijacked stars, gravitationally snatched from our galaxy's outer reaches, now streaming behind it like luminous tears. The merger, the slow, agonizing process of two titans becoming one, has truly begun. But this is no choreographed dance. It has only two partners, and absolutely no one, no cosmic entity, is calling the steps. It's pure, unadulterated gravitational chaos. 1 week later. 1 week. Just 7 days after the initial, devastating pass, and the universe around us is unrecognizable. Our sun's new orbit is a wild, unpredictable ellipse, a precarious path that now grazes the very outer rim of the newly forming galactic structure every 78 million years, less than half its old, stable period. This dramatic change has immediate, catastrophic implications for Earth. Our planet's climate models, already strained by human activity, simply break. They can't cope with the new, extreme variables. Winters grow longer, colder, harsher, as our solar system spends more time in the frigid, less dense regions of its new orbit. Summers, conversely, spike hotter, more intense, as gravitational perturbations bring us closer to the galactic core or through denser stellar regions. Cosmic ray showers, now a constant deluge rather than a rare event, seed clouds at unprecedented altitudes, turning skies pearlescent, giving them an ethereal, almost milky sheen. The light is diffused, softer, but also less direct. Photosynthesis, the fundamental engine of life on Earth, begins to adapt, slowly, painfully. Plants grow darker, broader leaves, desperately trying to capture every last photon from the hazy, altered sunlight. Evolution, usually a process measured in eons, is forced into overdrive. Astronomers, working frantically amidst the chaos, release an updated sky map. It's a shocking document. 40% of all familiar stars, The celestial landmarks that have guided humanity for millennia are now in the wrong place, their positions irrevocably altered by the galactic maelstrom. Astrologers, their ancient charts rendered utterly meaningless, quietly begin the impossible task of rewriting zodiacs, attempting to find new patterns in the cosmic pandemonium. Then, amateur telescopes, those humble instruments that first glimpsed Nemesis, pick up a new, incredibly bright dot near the galactic core. It's not a star, not a planet. It's the two supermassive black holes, now spiraling back together, their gravitational dance pulling in vast amounts of gas and dust. The whirlpool of infalling material shines brighter than the full moon, a new, terrifying beacon in our altered sky. The countdown to the real merger, the final, ultimate coalescence of these two cosmic giants, a process that will take another 100 million years, has officially begun. But for humanity, our familiar calendar, our measurement of time, has already been tossed out the airlock. We are living on a new clock, one governed by cosmic forces beyond our comprehension. What about us? So, the burning question, could civilization, our intricate, fragile human civilization, actually survive something like this? The short answer, surprisingly, is parts of it. The initial pass, as devastating as it was, strips away the layers of our technological dependence. Satellites, those eyes and ears above, are mostly gone, victims of debris and gravitational chaos. Power grids collapse, unable to cope with the surges and disruptions. Global logistics, the intricate web that feeds and supplies billions, grinds to a halt. Yet, crucially, the planet itself remains habitable. We weren't flung into the void. Coastal cities, once vibrant centers of commerce and culture, are tragically drowned under new, unpredictable tidal patterns, reshaped by the altered gravity and the moon's new, chaotic orbit. But inland farms, those resilient bastions of agriculture, pivot. They adapt, cultivating new strains of UV-resistant crops, hardy and dark-leaved, designed to thrive under the hazy, altered sunlight and increased radiation. Governments, recognizing the fragility of centralized power, decentralize, forming smaller, more localized and adaptable governance structures. The Internet, that lifeblood of modern communication, rebuilds itself, not as a single global network, but as a resilient patchwork of mesh networks, immune to orbital outages and more robust against local disruptions. Within a single generation, an astonishing transformation occurs. Kids grow up under the violet river of Nemesis, that immense, glowing presence in their sky, and they think it's normal. It's simply the sky star. They speak in new dialects, their language peppered with evocative, almost poetic terms like starburst season to describe periods of intense meteor showers, or gravity dusk for the strange, prolonged twilight caused by the new celestial alignments. They look up, not with fear, but with a new kind of wonder and pragmatism. They launch sounding rockets, not for exploration, but to mine the fresh stream of heavy elements, gold, platinum, rare earths, cooked in the recent, violent supernovae. These elements, once scarce, are now raining down, a cosmic inheritance. And in a strange, almost perverse way, they are grateful. The galaxy crash, this cataclysmic reset, forced humanity to break the climate deadlock, the political paralysis that no one could solve. The old ways of thinking, the old divisions, were literally shaken apart. Destruction, in this most profound sense, becomes creation, a brutal, undeniable truth that the universe, in its cyclical, indifferent grandeur, has always understood. It's how new stars are born, how new galaxies form, how life itself, against all odds, continues to find a way. The real science footnote. All right, let's bring it back to Earth for a moment, or at least, back to the science we actually understand. Here's the part where I, your humble narrator, remind you that the 2025 date for this galactic fenderbender is, emphatically, fiction. A thrilling, terrifying thought experiment. Yes, but not reality. The closest real collision on our cosmic calendar involves our very own Milky Way and its colossal neighbor, the Andromeda Galaxy. This epic encounter, often dubbed Milkomeda or Milkdromeda, is still a staggering 4+ billion years away. Think about that. By then, our sun will be well into its red giant phase, Earth might be a cindered husk, and humanity, if it still exists, will likely be a multistellar civilization. Recent studies, powered by over a decade of incredibly precise data from the Hubble Space Telescope and the European Space Agency's Gaia mission, have even refined the certainty of this future collision. Instead of being an absolute inevitability, the odds are now revised to about a 50% chance the two galaxies will collide within the next 10 billion years. Why the uncertainty? Because the gravitational influences from other galaxies in our local group, particularly the massive Large Magellanic Cloud, are subtly tugging and altering the trajectories of both the Milky Way and Andromeda, making their ultimate dance a little less predictable. When this actual collision happens, billions of years from now, it won't be a sudden, violent impact in the human sense. It will be a slow, majestic, gravitational embrace. The two galaxies will merge into a larger, more elliptical or lenticular galaxy. This process will indeed trigger intense star formation, often referred to as stellar fireworks, as gas clouds are compressed and ignite. Supernovae will light up the new galactic core. Our sun's orbit around the galactic center will be altered, possibly ejecting it farther from the new galactic core, but the Earth itself is unlikely to be affected beyond a change in its view of the new night sky. Crucially, individual star collisions are incredibly unlikely due to the vast distances between them. Stars, as we discussed, are more like cosmic billiard balls, mostly passing by each other rather than smashing directly. Over the next 150 billion years, all the galaxies in our local group will likely coalesce into this one supergalaxy, completing a slow, grand evolutionary process. So, while no observatory has spotted a nemesis galaxy hurtling towards us in 2025, and the idea of such an event happening next year is purely speculative, the underlying physics you've heard about is absolutely legitimate. Dark matter halos do collide. Stars do rarely collide, but their orbits are thrown into chaos. Black holes do dance and merge. Tidal stretching, starburst ignition, gravitational radiation, all these phenomena are real, verified aspects of astrophysics. Just not, thankfully, on next year's calendar. Still, the core takeaway remains the same. Whether it's next year or billions of years from now, the universe is a restless, dynamic place, constantly in motion, constantly evolving. And constancy, that comforting sense of permanence, is ultimately the true fairy tale. CTA. So, if you could somehow hop forward 1,000,000 years, or even 1,000,000,000, and witness the majestic, merged galaxy hanging in Earth's sky, a testament to cosmic transformation, would you press that button? Would you endure the chaos to see the ultimate outcome? Drop your answer in the comments below. Let's talk a little time machine ethics and the ultimate human curiosity. And while you're typing out those profound thoughts, do me a solid. Smash that subscribe button and hit the notification bell for weekly deep dives that turn impossible space disasters into your new, strangely comforting, bedtime stories. Want to know what living on a planet ejected into the cold, silent, intergalactic night would really feel like? The next video is already queued up, waiting to explore that chilling possibility. Conclusion. Galaxies crash. Stars migrate. Black holes waltz across the cosmos in dances of unimaginable power. The only true constant in this vast, sprawling universe is motion, incessant and relentless. And motion, inevitably, eventually brings collisions. Maybe not in 2025, not in our lifetime, but someday. When it happens, whether it's 1,000,000,000 years from now or, in our fictional scenario, tomorrow, the playbook for life, for consciousness, for humanity, is fundamentally the same. Keep looking up, keep adapting, keep telling the story. Because if we are still here, still breathing, still curious enough to watch two galaxies shred each other and then, from the ashes, birth a new generation of stars, then we've already won against the vast, indifferent dark. We've proven our resilience.